Okay. So good morning. I think now you can mark attendance here for the PT. Yeah. So okay. Yeah. So today I already marked attendance for 3 times. Yeah, means suppose 4 sections. I will mark for the first, third, and fourth. Okay. First, third, and fourth. Okay. So now we see for the next group. So next group PT 20. Yeah. Yeah. Okay. PT 20. Okay. Very fast. Okay. So the next group audit. Yeah. Yeah. Okay. Yeah. Audit. Yeah. Good. Okay. So now we see for the, don't worry, those who join late, we still can mark attendance for you. Okay. So we see the yeah. Okay. Okay. So for today, we just follow this schedule. At the break time from 10:30 to 10:30 to 11. Yeah, and then 12:30 to anyone to 1:30 or to 2? 2 is it? I think 12:30 to no to 1:30. So therefore, correct. Yeah, correct. So miss 0.5, 1.5. Okay. So 30 minutes, 1 hour, 30 minutes. Okay. Yeah. So you follow this. So altogether, 4 sections, but I mark attendance only 3 times. Okay. So you follow this. Yeah. Okay. Make sure you use the correct group. Yeah. Okay. So anyone, off your mic. Yeah. If for question, you can ask. Yeah. So off your mic. Yeah. Okay. Okay. So this is the planning for today. Yeah. So for yesterday class, we already finished the chapter 1, the introduction to the MMDA. Yeah. And then also started the chapter 2, the multiple linear regression. Okay. So any question you want to ask for the yesterday discussion? Yes. Okay. So, okay. Okay. So if now we see, we continue with our discussion yesterday. Yeah. Okay. Okay. So we are here. Yeah. So in stage 2, remember we got few stage. Yeah. In the multiple linear regression. Yeah. So first one, we should actually determine the objective. Yeah. So the objective of the multiple regression. Okay, we see a bit more detail the design. Okay, the research design of the multiple regression. Yeah. Before that, make sure you're ready. Yeah. Uh, Suppose we are using the SPSS in this section, but you stand by first. Okay. Okay. So we see the design. Uh, so we are here. Yeah. So we consider the sample size. Yeah. Okay. In general, more is better. Yeah, the sample size. Yeah. But again, still must consider the practical, okay, the practical significance. Okay. So let's say you got 2 million, n 2 million, you can separate it into few groups, few subsample. You do testing one by one like that, okay, to make sure that the result is more convincing. So the unique elements of the dependent relationship, you can use dummy variables, yeah, as independent. Okay. So okay. So sometimes we can use the dummy variable, yeah, as the independent. And we no need to separate it to two. Yeah. Remember I say in the yesterday, yeah, we got 6 years data. We can make it 3 year before COVID, and then after this another 3 year after when COVID started. Okay. But we have another method also to handle this. Yeah. Okay. So you can put 1 and 0. One during one no COVID. Yeah. That means before COVID. Yeah. So before COVID. Yeah. Okay. And then 0 means during COVID. Okay. Therefore you can get two equations. Yeah, we call this dummy variable. Okay. So use dummy variable as the independent. Okay. I think it's okay. Okay. It's okay. I think I do it now. Yeah, I do it now. Dummy. Because I mentioned dummy variables a few times already. But okay, we can start to do the analysis now. Yeah. Okay. Okay. So we use the SPSS and use the data that I already uploaded to the Moodle. Okay. It's okay. I give you 1 minute to open the SPSS. Yeah. So yeah. Okay. Another 40 seconds. Yeah. Okay, so done. I think Tan Chung Wei done already, is it? Tan Chung Wei? You mentioned to me just now, I already marked Tan Chung Wei. Here. Yes, correct. Okay, done. Tan Chung Wei, done. Okay. Okay, now we see the SPSS now. Okay, we see what is we see the normal case. Okay, we see the basic introduction of the SPSS. Then we see the normal case here of the multiple linear regression. Then we see dummy. Okay, so we see this now. Yeah. Okay. So okay, good question. Yeah. So good question. Yeah, very good. Yeah, thank you. Okay. So dummy and proxy. What is the difference between dummy variable and also proxy? Yeah. Okay. So dummy must be 0, 1, 2, 3 like that. Okay. Sorry, must be 0, 1. Must be 0, 1. Cannot be any other value. And then dummy must be categorical. Okay, yeah, very good question. Okay. Dummy must be categorical variable. Okay. So can be two or three groups, no problem. It's okay. Yeah. So let's say two groups, therefore will be 0, 1. Okay. Let's say three groups, example. Yeah. Example three groups. Three groups. Okay. Let's say the credit score. Okay. Okay. The credit score. Okay. Let's say for the application of the bank loan, yeah, rejected, and then KIV, yeah, and then approved. Okay. It's the decision made by the bank manager. Okay. So rejected KIV and also approved. Okay. So rejected, you can make it no KIV, you put it it's okay like this. Yeah. Like this means you should have two dummy. Yeah. Okay. Two dummy. Here let's say status 1. Yeah, and then status 2. Okay. So here is the first customer. I mean first application. Okay. And then here, let's say rejected. Rejected always 0. Yeah. Okay. So but this first one, this one let's say is the KV. Yeah. KV therefore here is 1, but the rest is 0. Okay. But for the approve, yeah, for approve, yeah, therefore here will be 1 and 0. Yeah, like that. Okay. So let's say here 0, 0. Meaning that will be rejected. Like that. Okay. So three categories. Three categories, you have a two dummy. We normally do D1, D2, like that. But it's not wrong, if you put status 1, status 2, not wrong. Yeah, okay. So this is dummy. Therefore can be 2 category, can be 3, can be 4. Let's say 4 categories. Yeah. Therefore you have 3 dummy. Okay. So for the proxy, the data can be metric. The data can be metric. Yeah. So example, actually proxy is more useful and then more frequently we use. Yeah. So you measure the company performance. Yeah. We discussed a bit just now. I know yesterday. Yeah. The company performance you use ROE. Therefore will be number. Return on equity can be 5%, can be 4%, can be 6%. The number. This is a metric. But this is not considered metric. It's just a different category. Okay.
Just to ask,
yeah.
Here you said okay, we have 3 status, rejected, KIV, and approved, but only we need the 2 dummies. So this is also due to the fact that because if we know the other 2 status, the third status is there. But just to check, if
No.
really
Okay. because we got two dummy, therefore we get three equation. Yeah. So this dummy, the rejected value will be represented by the intercept. Okay, this one will be represented by the intercept. Yeah. Okay. Yeah. Yes. Okay. Okay. Continue your question. Yeah.
I'm just to check if we really create three dummies for three status, what will happen?
So then the software will assume that you have four categories. Can I say?
Okay. So there will be a problem.
Yeah, problem. Okay. So this dummy. Yeah. So we see. Okay. Thank you. Okay. So now we see the basic first. How to use the what is SPSS? Okay. So at least in this first section, we try to finish these three things. Yeah. So okay. Means three things. First thing, the introduction to the SPSS, some basic. Okay. And then multiple linear regression, and then dummy. Okay. We'll see now. So now we can adjust a bit on the font size. Okay. So let's say 14, let's say 16. Yeah, a bit better. Okay. And then SPSS is quite similar with Excel, quite similar. But the difference is that Excel got many what they call you can increase the sheet 1, 2, 3. You can see you can increase a lot. I don't know how many, but can be a lot. Okay. And you will try, but can be a lot, I know. Okay. So but the SPSS only two. Yeah. Only two sheets. Yeah. Okay. You see the bottom left. Bottom left, data view and variable view. The bottom left. Okay. So they're showing the two button data view and variable view. Okay. So we see the data view is like this, showing the actual value. Right. And then variable view is for us to do the setting of the variable. Okay. And one more thing is that these two sheets they link together, they synchronize. Example, you see the variable view, um, the name, the second column name, representing the name of the variable, x1, x2, and so on and so forth. Let's say x1 I change to okay, I change to x1 gender. They will change it also here in the data view. Can you see the column x1 gender? Yeah. Okay. I change it back to okay. How to change it? You can press F2, F2 or just yeah, use your cursor, use your mouse. Okay. So x1. Therefore now they change also x1. And they link together. They synchronize. Okay. Okay. So if no question. Okay. Wang Shui Hong, I don't know what is the hot encoding. I'm not sure. You may explain a bit. Okay, basically dummy uh is artificial, yeah, but the purpose is to represent the categorical variable. So example, let's say COVID, you can say during pandemic or not pandemic, during financial crisis or not during financial crisis, like that. Okay, or maybe for the weather, some country maybe summer, okay, summer and non-summer, yeah, summer maybe business the economy better, business better, profit, earn more profit, right? This is dummy. But hot encoding, I'm not sure. What's this? Okay, we see. Yeah. And then, okay. So now is introduction to the SPSS. Type is normally we use numeric. Okay. Okay. And then here also quite similar with Excel. You can adjust the width like this. You can see, use your mouse. Yeah, you like this. Okay, same with Excel. In this context, same with Excel. Okay. Now you see name and label. So for the name, the name of the variable cannot be too long, and you cannot put comma, some special character. You can use comma and space. You can try comma, cannot. You see, cannot. It's illegal. Okay. I mean, it's illegal for the SPSS, not illegal in the real life, in the law. Okay. So spacebar also cannot. Okay. Okay. This is a name. But therefore, sometimes we want to use the label. You have to explain a bit more about the variable. Example, x1 gender. You can say x1 is gender. Okay. So, and then x4 is age, like that. Okay. You can also type a bit longer, including you can also use spacebar for the label. Okay. Okay. Now we see the values. Values actually is quite useful for the categorical variable. Right. Example here. So for gender, you no need to type male and female. You just use 1 or 0. 0 male, 1 female, like that. Okay. Okay. So means you type 0 representing male, 1 representing female, like that. Okay. So this is quite useful for the categorical variable. Another example, qualification. You can see primary, secondary, tertiary. Okay, different category. Yeah. Right. Now we see also X5 is common e-commerce activity. Yeah, like internet, online purchasing, and so on and so forth. Yeah. So this one is quantitative, meaning that this respondent can fill in any value between 0 to 10. Any value. Okay, 0 to 10. 10 excellent, 0 is very poor. Like that. Okay. So therefore, no need to use the label actually. I mean the values. Yeah, no need. Yeah, for the quantitative data. Okay. Then this one is also what we discussed in the first class. We got SPSS only got 3 categories. The measurement skill, 3 categories. Yeah, ordinal, nominal, and skill. Okay, can I see skill, ordinal, nominal? We can change. But of course, this is quantitative. Therefore, still remain. You are using the skill. In case you want to change, you can change this one. Okay, it's easy. Okay. Okay. So therefore, these 3 circles representing nominal. You have the ruler representing skill. You can also see it in here. Yeah. Okay. Compared to the old version, this now is a bit better because previously they didn't show this what they call this these are three circle and ruler. They just show X5. Therefore, not easy for us to know which one is the nominal or skill. Now it's a bit better. Maybe the new version. Okay. Okay.
So just to ask, if we have data in the Excel form and want to import into this SPSS, so we should what I call copy and paste in the data view, and we have to do the definition in the variable view.
Yeah, very good. Yeah, very good for the idea. It's correct. That's it. Okay, that's all we can do. Yeah. Therefore, it's quite easy. You copy and paste to the data view, and you adjust. You do some editing in the variable view.
It means the variable view will automatically do some categorization first.
No. You should do it manually. You should do it manually, but not much work because you already got data. Therefore, still easy. Yeah, you need to do manually. The sub editing.
Oh, so we set here. Okay.
That's correct. Okay. So let's say you get your data, you do questionnaire. You can also copy the questionnaire Yeah, same thing lah. Because with question A, you can generate Excel file. Excel file you can copy to SPSS like that. Okay. Okay. So okay, if no problem, that's the. Okay. And then we see a bit more on the instruction to the SPSS. So this one is I can say a bit more advanced. We can do okay. Not here, transform. Okay, not data, not in data. So in here, okay, we can do compute, variable, and so on and so forth. Okay. So, but we are more focused on the analyzer. Okay. So analyze, including we will do regression here, and then we will do here is for vector analysis. Okay. Okay, again so regression, okay, here. So from here we can do vector analysis, dimension deduction, then vector analysis. Here will be the discriminant analysis. Okay, yeah, here. Okay, so okay, so we basically done already for the first part. Okay, we can explore a bit more later. Yeah, for the SPSS. Yeah. Okay.
Sorry, sir. Can we use this SPSS to run the multivariate analysis?
Oh, this is what we are doing all multivariate data analysis.
Okay, got it, sir. Thanks.
Okay. So that's what we are doing. Multivariate method of data analysis. Okay. So we see now. Okay, we see how to do multiple linear regression. Okay. Now. Okay, we see the variable first. Okay. So we see the variables here. Okay. So we come to the multiple linear regression. We only want the metric. Therefore, we ignore the nominal. Use a scale. Okay. So we simply use, let's say, maybe we can do delivery speed and also the technical support affect the satisfaction. Okay, we do this now. Yeah, means that two independent and one dependent. Okay, we do this now. Yeah. Okay, analyze. Yeah. Analyze, and then regression, and then linear. Yeah. So analyze, regression, and then linear. Because this is a linear regression. Okay. Okay. If for me to repeat, I can repeat. Okay. Otherwise, I just proceed. Okay. So now we run dependent. So this column on the left side actually lists down all the variables that we have in this data set. Okay. So now we run the dependent satisfaction of the customer on this service and product everything. Yeah. Okay. So dependent only one. You cannot put two under the multiple linear regression. Okay. Okay. And then you can highlight technical support and also delivery speed. You can use the button control, the keyboard control. So to highlight two, you can see X6, X16. Yeah. Of course, you can also do it one by one, up to you. Yeah. So independent, you can move two. Use this button. You put in two variables here. Now you got two. Okay. Okay. So if no question, okay, I'll show you first. This one you need to use this for your assignment. Yeah, stepwise. You see, the stepwise is the procedure under the multiple linear regression. Okay, you use this. Of course, we will see this also. I think should be today. today we can finish, maybe can finish this chapter. Okay. So stepwise is for you to use it in the assignment later. Okay. So you see the basic first. Okay. Enter and then change nothing because this is only basic. The basic for the what, for the multiple linear regression. Okay. You just click OK. Okay. This is the output. Okay. Any question? Okay, give you 10 seconds. Make sure you can get the output like this.
Sorry, sir. What is the meaning for the method enter stepwise, remove backward and forward?
Okay, good question. So enter is the basic. We just follow the. I mean, this here they got two variables. They do everything. Yeah, that's it. Okay. But you will see the stepwise later. Yeah, don't worry. I must show you. Yeah. Today. Yeah. Okay. Okay. So stepwise actually is like you can consider like automation. Means what? Means the software. Let's say you put in 20 variables. The software will choose the best model for you. Like that. Okay. They do step by step. Therefore, they call it stepwise. Okay. So don't worry, we see later. Yeah. Okay. Okay. Wait. Okay, wait. Okay. Okay, categorical variable is transformed to numerical. It's so that the data now is a metric. It can do not like that. Okay, not like that. Okay. Okay, I can answer your question. I think if enough time now, yeah. Okay. Wang Shui Hong, yeah. Okay. So not because of this, because you must use 0 and 1 for the dummy variable. Okay. Okay, don't worry, I will show you. Yeah. Okay. Okay, it's correct. But this part you're supposed to learn already. Correct, in the data management. Yeah, you should do the grading, the example including handle the missing value. Of course, you will see this also later. Okay, I think should be today also. Yeah. Okay, we see how to handle the missing data. And also not missing the outliers. Okay, outliers. Yeah, a bit. Yeah. Okay. Okay. So continue. 10:30 is it? Okay, 10:30. It's okay. Okay, we see how much we can discuss. Okay, so we continue. Yeah. So you see the output here. Okay. So now we see the R square is quite high. No, not much. Normal. 0.332. Okay. So R square higher is better. In general, higher is better. So R square means the percentage of variation. Don't worry. I write down 332. 332. Don't worry. Okay. You will see it in a short while, but I want to show you the dummy variable. Okay. Now, yeah. Okay, 332. What is the meaning? Yeah. 0.332. So 0.332, therefore it's 33.2%. Yeah, okay. So you take the number, you times 100, you get 33.2%. Right. Therefore, this is the interpretation of the this value, yeah, 0.332. 33.2% of the total variation in the dependent variable can be explained by the independent variables. Okay, yeah. So this is the interpretation, yeah, of the R square. Okay. This is R square. Yeah. Okay. Okay. So okay, can discuss a little bit more. Yeah. This.
Sir, what do you mean by can be explained? Yeah?
Yeah, yeah, yeah. Now I'm doing. Yeah. Thank you. Thank you. Yeah. So yeah. One. Okay. I change the color. Okay. So now we got two independent variables in this model, also in our output just now. Okay. That we are doing. So remember we can interpret the beta 1 and beta 2. Yeah. So means we explain the dependent variable using the independent variables. Okay. So example, when the we see how to interpret the beta 1. Example, okay. So example, okay, delivery speed. Delivery speed 0.9. Okay, 0.9. Delivery speed 0.9. Therefore, we can interpret in this way when the delivery speed rating. This all the rating. Yeah, all the rating given by the customer on the company. Okay, when the delivery speed rating increase by a point. Yeah, then the what? The satisfaction of the customers will increase by 0.9. You can see, meaning that we actually use the independent variable to explain the dependent variable. Okay, increase 1 point in the delivery speed, therefore the satisfaction of the customer increased by 0.9 points. Okay, yeah. Okay, yeah. So this explain. Yeah. Okay. Means you explain the dependent using independent. Okay. So 33.2 means what? Means this two, we combine these two, we can explain 33.2%. The rest will go to the error. Error 66.8 percent. Okay, means what? Means what? Means here we only consider two independent variables, but there are still other variables that they can affect the dependent, but we did not consider it in this model. This model only consider two. Yeah, delivery speed and also technical support. Yeah, okay, and also technical support. Okay, so this is the meaning. Yeah. Okay, if no question, it's okay. I think dummy variable maybe after the second section. Okay, so now we continue. Yeah. So okay, so now we done already for the R square. Yeah, okay. For the adjusted R square, you can see the term adjusted. They adjusted for the what? For the number of independent variable and also the sample size. Yeah, basically these two things. Okay. So yeah, you can actually study this. Adjusted R square and also R square. Yeah. So this is a formula, but I cannot remember the formula. Yeah. So R square. Okay. When you increase the n, yeah, and also you increase the independent variables, the R square confirm increase. Yeah, but it just the R square they try to balance it. Yeah, try to balance it try to reduce a little bit. Means what? Means when you increase okay, we see first without adjusted R square. Let's say R square, the first case, yeah, R square, let's say 0.62, okay. And now your second, after this, you increase the sample size, yeah, increase the sample size, increase another 100. You add another 2 independent variables. R square confirm increase. Confirm increase. Example maybe 0.73 like that. Confirm increase. If you increase sample size and also increase the, you add another 2 independent variables. Okay. But you try to be a little bit more conservative. Yeah. So in research. Therefore, the adjusted R square is to you can say it's punish. Okay, punish the increasement of the independent variable and the sample size. Therefore, when you increase the independent variable and sample size, the R square increase, but the adjusted R square confirm drop. Example maybe 0.59, but must be below 0.73. Okay, therefore, means what means this method is to encourage you to find a good independent variable, not simply put in the independent variable. That is the reason. Okay. So therefore, here is a bit smaller. The adjusted R square is a bit smaller. Here you can see 0.318. Okay.
So, sir, you're saying that if the difference between R square and adjusted R square is very close, then the chosen independent variables are good.
Sorry. Okay.
I mean, you're saying that let's say if the difference between the R square and adjusted R square, if it's very close, then that means the independent variables that we chose is good, right?
Something like that. You can say like that. Okay.
If you chose wrongly, then the difference the gap will increase.
Okay. But we did not concern too much on the difference. We did not concern too much on the difference between these two. Yeah. Because some okay, straight to the point, yeah. Okay, straight to the point. Some supervisor they want the R square and adjusted R square to be reported in the capstone or thesis. Therefore, I just show you. But in statistics, F test is much more important. You see the next table, a normal table. You can see my cursor, the F. You can see, okay.
Mm-hmm.
It's much more important compared to R square. Okay, yeah.
Okay, and then how about the first R, the 0.576? Just to know.
Okay. Okay, good question. Okay. Don't worry. You want to know, I can show you. So this one is a partial. We call this partial correlation. There is partial. Here we got no, it's multiple. It's multiple. They combine the 3 variables and compute the correlation. Yeah, the 2 independent and 2 independent and also 1 dependent. They combine 3. They compute the correlation. Okay, this is yeah, it's correlation. Yeah, R. Yeah.
Okay, including the dependent variable.
Yes, correct. Including the dependent and independent. Yeah.
So we don't use this value as well, right? This
No, not much. Yeah.
not so significant to use. Okay.
Yeah. Okay. But okay, can discuss also a bit on the standard error. Can see 0.9748. Okay, the standard error of the estimate is the overall standard error. Therefore, smaller is better. Okay, smaller is better.
Mm.
So
The
R
sample
square
size
larger.
is smaller.
Again,
If the sample size increase, it will get smaller, right? As you said yesterday.
no. Again, sample size is smaller.
In sample size increase, then it will be smaller, right?
Question. This one I'm not sure. Okay, standard error of the estimate, but because we only because this one is also not too important. Yeah, but in general, is smaller is better. That's it. This is all I know. Okay, but I never study also how to link it to the sample size. Okay. Okay. So because
Okay.
F test is much more important. Okay. Yeah. Okay. We see ANOVA now. Yeah. Okay. So this F actually is Fisher. Okay. F means Fisher. Yeah. Therefore, be careful. Here must be capital letter. It's the name of the statistician who developed this testing. Okay. And this is the hypothesis. Yeah. Okay. Okay, the model is adequate. No, it's not adequate. Okay, and the model is adequate. Okay, yeah. Okay, so the F test is much more important actually. Yeah. So this is because some lecturer they are particular about the R square, but for me actually in fact it's not important. Yeah. Okay. Wait, yeah. Okay. Okay. For assignment, just report R square. Just report R square already good enough. Yeah. But I think assignment maybe did not ask you to do R square. I think no. Yeah. But either one is okay. Yeah. But if you want to use R, if you want to use adjusted R square, you should okay. If you want to use adjusted R square, you should use a bit different, statement. 31.8%. Okay. Okay. Yeah. 31.8%. Adjusting for the sample size. Yeah. Sample size and also the number of independent variables. Okay, that is yeah. So this is the yeah. This is interpretation for the adjusted R square. Okay. Okay. Next. Yeah. Okay. So we see. Wait. Okay. 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 Sunlight and plant height. Okay. R square 32. 32% of the variation in plant height can be explained by the variation of the amount of the sunlight. The other is affected by other factors. Is correct. Correct. So the higher the R square, the more the effect is correct. Okay, correct. So it's correct. So the higher the R square, the higher the effect of the independent on the dependent. That is correct. Okay. So R square is calculated from the sample. R square adjusted is calculated to estimate the population. Not like that. Yeah. it's not the difference between the sample and population. It's because adjusted R square we adjusted for the sample size and also the number of independent variables. Okay, that's it. Yeah. Okay. So continue. So this is the hypothesis for the F test. Yeah. So this is why I say the p-value make our life easier because the p-value is smaller. Yeah. Okay. P-value and alpha. Yeah. P-value 0.001. Alpha is 5%. Okay. This one discussed already yesterday. Yeah. Okay. So yeah. So p-value is small. Yeah. Less than 0. Okay. SIG is a p-value. It's very small value, less than 0.001. Therefore, we reject the null hypothesis. Okay. So reject the null hypothesis. Of course, let's say in your capstone, you should use a sentence. Yeah, not like that. Okay, use make a paragraph. Yeah. So we should reject the null hypothesis. Yeah. Okay. So if you reject the null hypothesis, meaning the null is not correct. We should support the alternative hypothesis. Yeah, that the model is adequate. Okay. So therefore, at 5% significant level. Yeah. So at 5% significant level, the model, yeah, the model is adequate. Okay, yeah, that's it. Okay, for the ANOVA. Okay. So F test is much more important okay, as compared to the R square. Okay, any question is? I think we take the break a little bit late because I want to finish this output. Yeah. Then after break, we come back for the dummy. Yeah. Okay. So okay.
So just now you mentioned in the ANOVA using the p-value, but how about the Fisher value of the 24.063? That is not p-value, right?
Good. Very good question. Yeah, thank you very much. Yeah, thank you. 24.063. Yeah. 24.063. Okay, good question. Yeah. So actually, this is the test statistics. Okay. And then 0.001 is the p-value. Yeah. Okay. This is test statistics for the F. The p-value for the F. Okay. Yeah. Thank you very much. Okay. So we see the concept still the same with the Z and the p-value. P-value can be for the Z, can be for the F. This p-value is for the F. Let's say for the Z, if the Z is 28, p-value confirmed must be very small. It's inverse relationship. When the test statistics is large, p-value must be very small. Here, same thing. The test statistics for the F is large, so the p-value must be very small. Small means smaller than 0.05. Okay, so this is the test statistics. If you want to use this, okay, but you must use the F table. This is a table also for the F. Okay, so for the F, again, I seldom use, yeah, but I still remember how to use, yeah. So we should use the degree of freedom 297 to find the critical value, yeah, from the table. Can you see? Therefore, F got table, T got table, Z got table, chi-square got table. Okay, therefore, this p-value is much easier for us. Okay. 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 If no question, now we see.
Sorry again, sir. For the DF, the DF is meaning degree of freedom or?
Yeah, correct. Degree of freedom. That's correct.
Okay.
Degree of freedom. Okay. We see how they compute this DF. Yeah. So for the regression tool, actually is referring to the two independent variables. Okay. And then 99 because n minus 1, 100 minus 1, 100 minus 1, n minus 1. Because we have 100 observations. Yeah. Okay. You can say 100. Okay. And then for the yeah. So 97, where is it? Okay, 97 because the n minus k minus 1. Yeah, means minus the number of independent and minus 1. Yeah. So this formula. Yeah. So n minus 1, therefore 100 minus 1 is 99. N minus k minus 1. K is number of independent. Therefore 100 minus 2 minus 1. Yeah, 97. Yeah. And that was k. Yeah, k is 2. 2 independent variables. Like that. Okay, so no problem. Okay, we try to finish this first this output, then we come back to discuss the dummy. Okay. So we see the coefficient. Okay. Okay. We suppose can copy. Just copy. Okay. This is also what you can do to do your assignment. You can copy and paste the output. Correct, like this one. It's very easy. Okay. So the output like this, we can do a few things. Yeah. So for the first thing already done. Correct. Okay. The first thing already done on how to interpret the what? How to interpret? Yeah, correct. This one. How to interpret the beta coefficient? Okay. So okay. Yeah. Can I see? So we can interpret the beta coefficient 0.909. Okay. So delivery speed. Okay. So we see move must be increased. Yeah, the first one must be increased. Second also increase. The second increase because here is plus. Okay. So we can do the same thing for the technical support. Okay. And then we can also write out the equation, yeah, based on this. Okay, based on this. Yeah. So therefore here we get y equals to 2.982. Okay, y is the dependent variable. This is intercept. Okay, 0.074 x6. You follow this x6. Okay, and then plus 0.909 x16. Done already. Okay, this is the second thing that you should do based on the output. You interpret the output. Okay. Okay. So if no problem, now we see a bit one more thing for the constant. Yeah, the constant is 2.982. Okay. The constant sometimes got meaning, sometimes no meaning. Okay. So I mean for this context, looks like no meaning. Okay. Looks like meaningless. Okay. But anyhow, we still can interpret because sometimes it's meaningful. Sometimes. Okay. So we see what is the meaning of 2.982. Yeah. Yeah. 2.982. Okay. When the technical support rating and derive very speed rating 0. Yeah. Then the is friction yeah, T. Will be, okay, like this, yeah. Okay. So therefore, that's why I say in this context it looks like meaningless. Because you see the logic, the nickel support 0, means it's very poor. Okay. The average speed also 0, but still got some point. Well, maybe this point from other factor, yeah, maybe still logic, yeah. Okay. Okay. So this is the how to interpret the constant. Okay, 2.982.
So does this constant also include the error?
No, constant is constant, error is error. Yeah. Okay. Constant is constant, error is error. Okay.
Okay, so the error, it seems
The error by definition is 0. Yeah. Okay. Because okay, so the error should be 0. Yeah. Okay. Good question. Yeah. Thank you. Yeah. Thank you. Thank you for the question.
yeah, both because both are like a constant, right? Error also could be a constant, right? So it's like
No, error is not constant. Error is error actually is not okay. A little bit technical. Okay, but don't worry. I show you this now. Okay, so error actually should be 0. Yeah, the expected value of the error term actually is 0. Yeah. Okay.
is 0 for every case or just this case specifically?
Okay. Okay. No problem. I'll show you. No problem. Okay, you see the simple linear regression. Yeah. Actually, we have this in the slide. We have this. Yeah, I'm sure. Yes, correct. This one. Okay. So you see x and y. Okay. You see the yellow dot all representing the data point. Okay. So therefore, some a bit higher, some a bit lower. Let's say you draw the line, the blue color line actually is a linear line that can be calculated using the software. Okay. But the blue color line is the best. Let's say you use this color, this line. Line number 2 is not good. Because line number 2 is far away from the data point. Therefore, it's very bad. Not accurate. Cannot be used to represent the data point. Line 1 is very good. Okay. Next. Now we see what is error. Okay. So at this point, at this point, x, let's say x is 12. Yeah, x is 12 from the software. The software gives you this value. Let's say 9. But the actual data point is 10. Therefore, the error is 1. The error is 1. Because the predicted value and the actual value different. Yeah, it's a deviation not explained by the regression. Okay, altogether 10, but they can explain only 9. 1 point cannot be explained. Therefore, go to the error. Okay, but some error is positive, sometimes negative. Example, this point is negative. Okay, therefore you total the error will be 0. And actually we use power 2. No, sorry, total. Yes, correct, error. Not power 2, total. Okay, so total error is must be 0. Yeah, therefore you see when we write the equation, we put when you do the general equation, we put error. But when we come to the interpretation, no error. Because the error is equal to 0. Yeah. Okay. Yeah. At least you can see no 0. No error. Okay.
So it seems like that means we have to plus the error to get the actual value, right?
Not like that. Not like that. By theorem, the error is 0 because this is the expected value actually. Okay, you see the logic. Not here. Not okay. Wait, yeah. Yeah. Can you see some points above, some points below? Yeah, therefore, is the sum of zero must be sum of error must be 0. Yeah. So okay. So I think it's okay also for us to ignore this point because as I say, sometimes this point got meaning, the constant got meaning, sometimes meaningless. Okay. Okay. So, but I explain it to you now because we are going to use this constant also when we discuss dummy. Okay. We see. Yeah. Any question from you? No, we cannot say lower constant good or not good. Not like that. Yeah, not like that. Yeah. Okay. Okay. Not say good or not good. This is only the value. Yeah. Okay. Some of you may learn. It's okay. I think no need to be so complicated. Okay. How you get 3 by 364? Oh, okay, it is different. Okay. You use the stepwise. Okay.
Stepwise.
Okay, x6. Wait, yeah. Okay. So, wait. What is the comment again? X6 to be excluded. Basically, your idea is correct. Yeah. Because x6 is not significant. Yeah. Okay. Next what we are going to do now. Yeah. Because x6 is not significant. The p-value is very large, more than 0.25, more than 0.05. Therefore, the x6 is not significant. X16 is significant. Okay, in this model. Okay. So we see next thing that we can do is the testing of the individual variable. Yeah. Okay. Beta 6. Okay. Beta 6. Therefore, beta 6 referring to the technical support 0.251 is the p-value. Okay. So again, T is the test statistics T. SIG is the p-value. Okay. Therefore, you see when the T is small, 1.1 something, the p-value is large. Yeah. When we compare, why we say large? Because we compare with the 0.05. Okay, it's much larger compared to 0.05. But for the delivery speed, the T is very big. It's 6 point something. But the p-value is very small. Okay, less than 0.001. Okay. Before I show you one listing for the technical support. Is technical support or what? Yeah, technical support. Yeah, technical support S6. Okay. So therefore p-value, again p-value is very convenient for us. Yeah, 0.251, larger 0.05. Okay. Therefore, do not reject. Okay. Do not reject the null hypothesis. Okay. So we see the difference between the F and T. Yeah. Looks like quite similar, but F is to test the overall model. We combine the two independent variable, they do testing, yeah, at the same time. But the T test, we test one by one individually. Okay, we test it individually. Okay. So I mean, I will show you the stepwise later. Yeah, but now we see the general case first. Okay.
So just to ask, yesterday you said this SPSS will use the T statistic. So I suppose just now the ANOVA, the F value is also a T statistic rather than a Z statistic.
No. ANOVA different already. Yeah.
Ah.
ANOVA different. ANOVA is not the T. Yeah.
So you use a Z now. Okay.
Okay. No, ANOVA is F, not Z. Okay, ANOVA different already because they compare the variance. Therefore, it's F. Yeah. So cannot use T or Z. Yeah. So for the mean, yes, T, but the F is for they compare the variance. Okay.
All different formula. Okay.
Yeah, different formula. Okay. So we see next. Okay. So therefore, we cannot reject the null hypothesis because p value is really is much larger compared to alpha. Okay. So therefore, based on this testing, we can say that X6, which is the technical support, okay, technical support is not affecting, yeah, it's not affecting the satisfaction. Okay. So this one is only testing for one variable, but the ANOVA testing for the whole model. It's the difference between T and F. Okay. Okay. So any question? Yes. It's correct. Correct. By default they use 5%. Correct. Actually, not only SPSS. Yeah. In many capstone disease also by default 5%. Okay. Unless it's more to medical, they want 1%. Okay. Yeah. Wait. Okay. The error under the multiple linear regression, the error, we did not show the error. Yeah, the error is 0. Yeah, by definition. Yeah, by theorem. Yeah. Okay. The standard error of the estimate, this standard error, not the error, different thing. Okay. They got different formula to do calculation. Yeah, for the standard error. Okay. So it's not error. Be careful. Yeah. Standard error and error, different thing. Yeah. Okay. Okay. Yeah. I think I still one part no answer about the dummy. Yeah, dummy I will show you after this. Okay. Okay. So any question? Yes.
One more, sir.
Yeah.
So on just now the coefficient, we use this unstandardized coefficient. So there's another column on the standardized coefficient that the constant is there's no value for constant. So
Okay. Yeah. So we see now. Yeah. Thank you very much. Okay. So we see the standardized coefficient beta. Okay. So constant of course are not nothing because the standardized coefficient is only for us to see which variable is more important, which variable can affect the dependent variable more. Therefore, only the variable show the value. Okay. Therefore, here, I like what your friend mentioned just now. Right? I think got one mentioned just now. Yes, correct. This one, correct. Okay. Wang Shui Hong. Yeah. So therefore, it's correct to say that it's correct for us to make a conclusion that the existing is much more important compared to technical support because of the standardized coefficient. Okay. Of course, we can know this also from the p-value, but the p-value for the existing is significant. Therefore, existing is much more important in affecting the dependent variable. But sometimes the p-value may be similar. Let's say p-value 0.01 or 0.01. Therefore, you can see the standardized coefficient beta to see which variable is affecting the dependent variable more. Okay, like that. Okay. But the unstandardized is important for us to write down the equation. Yeah, different purpose.
It seems like the standardized coefficient is making the lines to go through the 0 points, right? So there's no intercept.
Okay, your question, your point.
No, it's standardized coefficient is just like to tilt the line, just to make sure there is no intercept on the y-axis.
No, not because of that. Not because of that. Yeah, because
Oh, no.
you want to, this is for us to see which variable can affect the dependent variable. But constant, of course, is not variable, no data. Can see constant, yeah.
By taking away the effect of constant, something like that.
Not like that. Not. You cannot say taking away the effect of constant because it's something. The constant is not data, but X6, X17 got data. They only consider the independent variables, not constant. Okay.
Oh, okay.
Okay. Any other question? Yes. Okay. So yeah, okay. Miss, now we take a break. So see you at what time? Yeah. Okay. I think yesterday sometimes got technical issue. That's why I use a new button. But if nothing happened, I use the same button for the next section. Okay. So okay. So now 10, 11:20. Yeah. Yeah. So 11:20 we continue. Yeah.
Okay, thank you. See you, sir.
Great. Okay. Thank you.